Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 2, that is Electrostatic Potential and Capacitance. Class 6. From Basic to Advanced Level, for Board, JEE, KCET, and NET. Do support watch till end, don't forget to comment, share, subscribe the channel. In previous class, we finished electrostatic potential part. That video link is given in description, don't miss it. Today, starts with capacitors. Let's start. Capacitor. Capacitor is a system of two conductors separated by an insulator to store electric charge and electric energy. Let's understand with diagram. A capacitor consists of two conductors having charges plus Q and minus Q, and potential V1 and V2 as shown in figure. The potential difference between the plates. V is equal to V1 minus V2. Here Q is called the charge on the capacitor. It is equal to the charge on one of the conductor. But the net charge of the capacitor is 0. That is plus Q minus Q is equal to 0. In general, Q is equal to charge of the capacitor. V is equal to potential difference between two conductors. Capacitance of a capacitor. It is found that potential difference is directly proportional to charge. That is, V directly proportional to Q, or Q directly proportional to V. This can be written as Q is equal to CV, where C is constant called capacitance of the capacitor, or C is equal to Q by V. Definition. Capacitance of a capacitor is defined as the ratio of charge on a capacitor to the potential difference between two conductors of the capacitor. S.I unit is coulomb per volt or Farad, F. Next. Definition of Farad, denoted by capital F. Capacitance of a capacitor is said to be 1 farad, when one coulomb of charge given to it increases its potential by 1 volt. That is, C is equal to Q by V. If Q is equal to 1 coulomb, V is equal to 1 volt, then C is equal to 1 farad. Then, 1 farad is equal to 1 coulomb by 1 volt. That is, 1 farad is equal to 1 coulomb per volt. Farad is very big unit. In practice, the smaller units of Farad is used. They are 1 millifarad, symbolically written as MF. Here, 1 millifarad is equal to 10 to the power minus 3 farad. 2 microfarad, symbolically written as μF. Here, 1 microfarad is equal to 10 to the power minus 6 farad. 3 nanofarad, symbolically written as NF. Here, 1 nanofarad is equal to 10 to the power minus 9 farad. 4 picofarad, symbolically written as PF. Here, 1 picofarad is equal to 10 to the power minus 12 farad. Next. Factors on which the capacitance of conductor depends. Capacitance of conductor is the capacity to hold the charges given to it. It depends upon the following factors, they are 1. Shape and size of the conductor. 2. The nature, permittivity, of the surrounding medium. 3. The presence of other conductor near it. Next. Symbols of capacitors. A capacitor with fixed capacitance is represented with this symbol. And a capacitor with variable capacitance is represented with this symbol. Next, expression for capacitance of an isolated spherical conductor. That is, C is equal to Q by V. That is written as C is equal to Q by 1 by 4 pi epsilon naught into Q by R. On cancelling Q from numerator and denominator, we get C is equal to 4 pi epsilon naught R. This equation is for when conductor is placed in air. Similarly, C is equal to 4 pi epsilon naught epsilon R into R. This equation is for when conductor is placed in medium of dielectric constant. The capacitance of a spherical conductor depends on 1. The radius of conductor. 2. The dielectric medium surrounding the conductor. Next, parallel plate capacitor. A parallel plate capacitor consists of two metal plates parallel to each other and separated by a small distance. Let's derive an expression for capacitance of parallel plate capacitor in absence of dielectric medium. Proof. Parallel plate capacitor consists of two parallel metal plates separated by a small distance. The space between two plates to be vacuum. From diagram, let this is plate 1 and plate 2. Are the two metal plates parallel to each other and separated by a small distance d? A, be the area of each plate. Here small d is distance between two plates. Plus q and minus q are charges on two plates. Plus sigma and minus sigma reference surface charge densities. And E, be the uniform electric field between plates. We have C is equal to Q by V. Mark as equation 1. And sigma is equal to Q by A. Mark as equation 2. Electric field due to plate 1 is E1 is equal to sigma by 2 epsilon naught. Mark as equation 3. Electric field due to plate 2 is E2 is equal to sigma by 2 epsilon naught. Mark as equation 4. In the region above the plate 1, E1 and E2 are in opposite direction. Therefore, net field above the plate 1 is E is equal to E1 minus E2. Substitute E1 and E2 values. That is equation 3 and 4. We get E is equal to 0. Similarly, E1 and E2 are in opposite direction in the region below the plate 2. Net field, E is equal to 0. Similarly, in the inner region between plates 1 and 2, E1 and E2 are in same direction. Therefore, net field E is equal to E1 plus E2. On substituting values, that is, E is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. On cancelling 2 from numerator and denominator, we get E is equal to sigma by epsilon naught. But E is equal to V by D. Substitute in above equation we get V by D is equal to sigma by epsilon naught. Therefore, on equating, V is equal to sigma D by epsilon naught. Mark as equation 5. Substitute equation 5 in 1. That is, C is equal to Q by V. On substituting V value we get C is equal to Q by sigma D by epsilon naught. Taking epsilon naught to numerator, we get C is equal to Q epsilon naught by sigma d. Mark as equation 6. From equation 2, that is, sigma is equal to Q by A. On equating this equation, Q is equal to sigma A. Substitute this in equation 6. C is equal to sigma A epsilon naught by sigma d. On cancelling sigma, we get C is equal to A epsilon naught by d. This is the expression for capacitance of a parallel plate capacitor. Note: in case of a parallel plate capacitor, near the outer boundaries of the plates, the field lines bend outward at the edges. This effect is called fringing of the field. Next, derive the expression for capacitance of parallel capacitor when dielectric medium is present. Proof. Case 1. Consider a parallel plate capacitor. The space between the plate is vacuum. Let Q is charge on capacitor. V0 is potential difference. E0 is electric field between plates. Sigma is surface charge density. A is area of each plate. D is distance between two plates. Therefore, E0 is equal to sigma by epsilon naught. Case 2. When a dielectric medium is filled between two plates of a capacitor, then dipoles are induced. Let sigma d is surface charge density due to polarization of dielectric. Ed is electric field due to polarization. But Ed is equal to sigma d by epsilon naught. Therefore, net electric field E is equal to E0 minus Ed. On substituting values, E is equal to sigma by epsilon naught minus sigma d by epsilon naught. That is equal to sigma minus sigma d by epsilon naught. It is found that sigma minus sigma d directly proportional to sigma. Therefore, sigma minus sigma d is equal to sigma by K, where K is dielectric constant. Therefore, E is equal to sigma by epsilon naught K. Mark as equation 1. We know that E is equal to V by D. Equation 2. From 1 and 2, sigma by epsilon naught K is equal to V by D. On equating to sigma we get sigma is equal to V epsilon naught K by D. But sigma is equal to Q by A. On substituting, Q by A is equal to V epsilon naught K by D. On changing V and A, we get Q by V is equal to epsilon naught Ka by D. We know that Q by V is equal to C. Therefore, C is equal to epsilon naught Ka by D. Or C is equal to epsilon naught epsilon Ra by D. Next, expression for relative permittivity, dielectric constant, in terms of capacitance. Capacitance of parallel plate capacitor in absence of dielectric medium is Ca is equal to A epsilon naught by D. Mark as equation 1. Similarly, capacitance of parallel capacitor when dielectric medium is present is Cm is equal to A epsilon naught epsilon A by D. Mark as equation 2. From equation 1 and 2, Cm by Ca is equal to A epsilon naught epsilon A by D by A epsilon naught by D. On cancelling common terms, finally we get Cm by Ca is equal to epsilon A. Therefore, on equating to Cm, that is, Cm is equal to Ca into epsilon r. This is expression for relative permittivity in terms of capacitance. Now let's see factors on which the capacitance of parallel plate capacitor depends. Capacitance of parallel plate capacitor is 1. Directly proportional to the area of each plate. 2. Inversely proportional to the distance between the plates. 3. Directly proportional to the dielectric constant of the medium between the plates. How can you increase the capacitance of parallel plate capacitor? The capacitance of parallel plate capacitor can be increased by 1. Increasing the area of the plates. 2. Decreasing the distance between the plates. 3. Using a medium of high dielectric constant between the plates. In the next class we discuss series and parallel combination of capacitors. So don't forget to comment, share and subscribe the channel for more updates.